Okay, guys, good morning. Let's continue with the part two. Okay, but before doing that, I would like to shout out to the guys who put their comments in part one. Thank you for keep on supporting my channel. Okay, actually, these tutorials are for beginners who are really wishing to join this very exciting field of engineering, building automation. Now, guys, our approach is to have a short example, use some blocks, and we will try to understand what are the functionality of a block. Okay, so far, just to wrap it up or have a review, we already used around 1, 2, 3, 5, 6, 7, 8. So we already have 8 blocks. Okay, now, guys. As I really emphasized, before you do the programming, you need to consult first the approved sequence of operation. Now, this is our sequence of operation. Let's try to build up the sequence of operation, okay, so that we can use new blocks, okay. Now, let me, so I will try to put some more comments. Okay, wait a minute. Let me just copy this. Control C, Control V, okay, then we will put it here. Okay, now I will just try to add some, okay, but anyway, just wait. It, okay, so I will just copy this. Maybe I will just copy this one. Sorry. Okay, anyway, Control V, let me do this. Okay. Oh, okay, then that is the easiest way, okay. Now, for what we will do is, I will try to write here. So, start EF when it is in automatic mode, off when there is fire alarm, off when there is EF trip. Okay. Now, one of the tasks that you need to provide for this kind of equipment is to know the runtime. Okay. So, we will try to use a runtime block. Okay. Now, monitor. Okay. I will say monitor the running hours of the fan. Okay, then let's add more. Okay, then monitor the running hours of the fan. Then raise an alarm if there is a problem. Okay, when I say problem in the fan motor, so we are repairing the trip. Okay, now maybe that would be enough. Okay. Okay. So the sequence of operation, we tried to build up our sequence of operation. We added monitor the running hours of the fan, raise an alarm if there is a problem in the fan. Okay, now when I say raise an alarm in the motor of the fan, then uh, the condition there is the trip condition in the fan. Okay, so let's try to develop our logic. Okay, the added monitor the running hours. Okay, now before we can monitor the running hours, we need additional input blocks. So we need to add an input block here. Okay, so first, how do we know or what are the inputs that we need to use so that we can start the runtime accumulation, or we start the counting of the running hours of our equipment? Okay, So we need a black here, okay, simple black. Then we need a DI. DI stands for digital input. Okay. Now, as I said, these are the physical points. Again, physical points are the points taken from the field. Okay. So here I will say now this one is my EF1, okay, and status. So meaning if I give the command to run the fan, I should receive an on signal or a run signal. Okay. So no need to specify the unit here. Now description, okay, I will not uh, define the description here because it is obvious that is the running condition of the fan. Now, again, we need to specify the input module wherein we will connect the cable from the motor control of the fan to the digital input of the DDC. Okay, so I connect it to export. Okay, so meaning we already have 4 physical points here. Okay, so run hours. Now, to be able to monitor the run hours, we need a block that will do that job. Okay, so again, simple block. Now we have here an RT block. Now RT block is runtime or runtime totalizer, something like that. Okay, so this will be the block that I'm going to use. Okay. Now guys, actually if you are doing some function block programming, make sure your input lines and output lines are organized. Or if I'm the one doing, I don't want my these lines is crossing other lines, something like that. But sometimes if your logic is very big, then of course it's not avoidable. Okay, so anyway, I hope you get my mm, point. Okay, now first let's try to understand what is this runtime block. Okay, now runtime block, as you can see here, okay, let me uh, edit the black RT. Okay, now there are 2 inputs and 1 output here. Okay, now okay, first thing that we need to do is give an identifier for this one. So this one is obviously EF1 run hours. I will say run hours. Okay, now guys, pay attention also on how I'm trying to define the identifier. Okay, now I have here the public. As you can see, it is not check. Okay, now what is the purpose of this public? Guys, later on, you will be creating graphics for this equipment. So if you will not click this public, you will not be able to bind this point, or you will not see this point in the server. Okay, so that is the purpose of the public. You have to click it so that it's visible. When you say public, you want to share it. Okay, in the server so that you can use it in binding some of the this point to some of the graphics. Okay, so unit, okay, unit here now this time. Okay, so there is no unit here, but there should be some unit here. Okay, anyway, we will specify the unit later. Okay, description, okay, I will try to put some description here. Runtime accumulation. Okay, so I would say runtime accumulation. Then now the unit is, it will start with 0. Okay, now 0 is for counting the hours. 1 is for counting the minutes. Then 2 is for counting the seconds. Okay, now actually this is run hours, so obviously you should start with 0. I mean, you have to use the parameter unit 0. Okay, but for the sake of testing, you can use the minutes. Okay, so we will use minutes because when you are trying to test or simulating your control, you don't want to wait 1 hour before you will see some output in the runtime block. Okay, so that is the purpose of why I'm using minutes. Okay, now, okay, so we have 2 inputs here. Now I stands for the input that will start the counting or the runtime accumulation. So we need that one. So what we're going to use for that one is our, obviously, we will be using this. Okay, so I will try to make my logic neat. Okay, but if you don't have the luxury of time, you can always, especially if you are pressured in the site, then your project manager will say finish the programming within several days. Then maybe you will not be very careful in your uh, function block programming, especially these lines. Okay, these nodes. Okay, now I already have provided the input. Okay, then I will provide here the RS. Now RS is for the reset. Okay, now actually man hours is very important in maintenance. Okay, now let's say I am the chief engineer of the building. I will say, okay, Mr. Programmer, if this equipment runs around 500 hours, raise an alarm, then uh, so that my BMS operator will be able to relay this alarm to the maintenance people so they can do the necessary preventive maintenance for the equipment. Okay, preventive maintenance, maybe they have to lubricate the bearing of the motor, or if it's driving a fan, likewise, if it's a belt driven, they have to tighten the belt, something like that. Okay, then after doing the maintenance, then the maintenance people will notify the operator. Okay, then you can reset the run hours. Okay, now actually these alarms should be logged. Okay, for the there should be some history. When did you actually, when I was in the maintenance, we are doing this maintenance job for this equipment, then it will be checked from time to time. When did you perform the preventive maintenance for this equipment? Okay, now as I said, guys, I'm doing a very detailed programming and explanation for the sake of the beginners. Okay, now for the reset, actually there are several blocks that you can use, but we will use here some simple block like parameter value binary. Okay, so I can use this PVV. Okay, now again you need to make this okay, you can make it public, or you can uh, leave it unchecked. Okay, anyway, we will make it public. Identifier, so the identifier for this one is EF1. Okay, let me abbreviate runtime RST. So meaning this is for the resetting of the accumulated run hours. Okay. Now I don't need to specify now zero, since this is binary, parameter value binary. So the initial value is zero. Now when we say binary, there are two possible values, 0 and 1. 0 meaning you are not resetting. If you make it 1, you are resetting the runtime accumulated. Okay. So let's leave it to 0 there. Okay. Now let's connect our output here to our RS. Now monitor the running hours. Okay, we already have the running hours here. Then raise an alarm if there's a problem in the fan or fan motor. So we are referring to the fan motor here. So the condition here is to raise an alarm. Okay, so I need another block to raise an alarm. So we have here alarm block. Okay. Okay, so this is an alarm block. Okay, let's see if we can insert it here. Okay, very good. Now, raise an alarm if there is a problem in the fan. Okay, so I will, actually, I can create a node somewhere here. Okay, so let me create a node here. Right click, then create a node. Okay, so that is a node. Again, I want to make my program neat. Okay. So when it trips, I will raise an alarm. So this is number 5 here. So when EF1 trips, then raise an alarm. Okay. Now let's talk about this alarm block. Now, identifier, obviously, it will be always necessary to identify the block. Okay, so this one is EF1 trip alarm. Okay, now this alarms are very important in the BMS or building automation system, because for the maintenance people, they should be aware that the equipment is an alarm condition. Okay, so that's why it is very important that always monitor the trip condition. Okay. Now let me just explain the trip. What is trip? When the motor is in a trip condition, there is one possible reason for that one. The motor went in an overload condition. Now, when we say overload, let's say the motor full load current is 2 amperes, okay? Then for the magnetic contactor, for that fan, we are using an overload relay. Then we set the setting. Let's say the full load current of the motor is 2 amperes. Now we are setting the trip set point to around, let's say, 2.1, 2.2. So meaning if the motor is drawing current more than the full load current of the motor, then it should trip. Okay, so that is the purpose of these overload relays, to prevent the further overheating of the motor winding, because if you will not provide any protection there, eventually the motor windings might burn. Okay, so this is the importance of overload relay. Okay, now description, we already know that this is for the trip. Okay, now delay on, so you can also specify. For the time being, all these delay are set to 0. Okay, delay on, maybe you can leave it, because immediately we want to raise the alarm. Delay off also. Okay, when it is not there, okay, your trip alarm should go away. Okay, now priority 0, OP alarm text. Okay, now this OP alarm text, we will say EF1 trip, EF1 trip alarm. Okay, now alarm text, let's see what will this edit means. Okay, trip alarm, then reset alarm, trip EF1 trip back to normal. Okay, so when the alarm is reset, then the text should display EF1 trip alarm back to normal. Okay, so let's do that one. Let's keep it. Okay. And now for the priority, later I will show you the priority, but we can say, because there is some higher priority, something like that. Okay. Anyway, we will just leave it for 0. Okay, later maybe I will try to explain it. Okay. Okay. So I already see. I already satisfied this sequence of operation. Okay, so let's just skip that one. Okay. I don't want to really create so many things in here, because this is a detailed one, so that I can explain it clearly. Okay, now, okay, so this will be our final function block control logic for this sequence of operation. Now let's try. Okay, anyway, before we simulate it, now these points, trip alarm, then run hours, EF1 RT reset, this one are software points. Now when you say software points, these are not associated with cable. So we are generating these points inside our control logic program. Okay, so when we make this public, it will be available in our server, so that we can use it in binding our graphic. Okay, now let's save it. Save. Okay, if there is no error. Now usually error is when you used illegal identifier like backslash and other special characters like asterisk. question mark, and so on. Okay. Then when there are some input, let's say this I, it is not connected to anything, then it will give you an error also. Okay. So let's see if we can simulate it. Okay. Now let's see if we can simulate. Again, we want to click the execute so that our program will start cycling. When we say cycling now, the let's say the program or our compiler is trying to scan all the inputs, then produce the necessary output. Then again, it will keep on repeating this cycle. Okay. Now, okay, so start when it is in automatic. So I will put it in automatic. Obviously, my fun is I'm giving now the start, or I'm giving the command to start the fan as you have seen here in the DO. EF1 start to stop. Okay. Now, of course, uh, our run hours will not start to count. Why? Because for the input I, it should be in high signal or 1. Now, what we are using here is the run status. Okay. So we give the command to start, then obviously we are expecting to receive a run status. Okay. So let's say we receive the run status, then that's the only time our runtime accumulator block will start to count the run hours. Okay. Now this is the purpose why I use the 1 unit there. Okay. Because if I will use 0, then it will take some time. Okay. Now, but for the simulation, it will not be very long. But I don't want you to wait. Okay. So as you can see here, it will start to count the runtime. Okay. Okay. Now, the reset is, let's say you want to reset. Now let's remove the run hours. So it will stop counting. Okay. I mean the run status. Now it will stop at 24. Now for some reason you want to reset it. This is just for simulation. Enter. Then it goes back to 0. The accumulated run hours here. Now guys, what is important here? This reset should be removed. Okay. So enter. You should have, when you reset it, the unit will become 1, meaning you are resetting this one. But you have to return it to 0, because if not, the runtime will be always resetted back to 0. So that is the purpose why when you reset, put back the reset to 0. Okay. Now, okay, so I have shown you already the run hours. Then let's see how this trip alarm behaves. Okay, so let's say we have a trip condition in the fan. Okay, obviously the trip alarm will be raised, then likewise the fan will be stopped. Okay, now let's try to remove the trip. Again, the fan will start. So I hope you are seeing how it works. Okay, so I think this will be enough for the part 2. Then just keep on checking the playlist for this tutorial, because every day I will try to do more programming so that I can help you guys out there. Okay, so once again, thank you very much for joining me in these short video clips, and I do hope these things will really help you guys who are wishing to join this field of engineering. Thank you very much for joining, and of course, before I will end, God bless us all. Let's all be safe. Bye for now. Thank you. Please subscribe if you have not done so. Then you can always put your comment, and you can like and share the video. Thank you. Bye for now.